Welcome to AI Podcasts. Today we're digging into a new EMNLP paper on training AI agents to plan better. Short version first. The authors show that if you train the planning brain of an agent by rewarding good tool use, you can lift planning by roughly 8 to 12%, and the final answers improve by around 5 to 6%, even though you never trained the answer generator itself.
That's a neat headline. Who's behind it?
Zhiwei and colleagues, including Yong, working with WeChat AI at Tencent and Peking University. The work was done while the team was interning at WeChat AI.
So, what problem are they tackling exactly? I keep hearing planning and summarizing as separate things, but they usually get trained together, right?
Right. In most agents, you have two jobs. First, plan which tools to call and in what order. Second, take the observations and write the final answer. The standard recipe tries to train both at once and scores the agent on whether the final answer looks good. The catch is that reliable answer grades are scarce in the real world, and when you use a learned judge, you can get reward hacking. Plus, when planning and writing are optimized together, the gradients fight for attention. Credit gets misassigned. The planner does the right thing and the summary messes up, or the opposite, and the signal is noisy.
So their fix is to stop grading the essay and grade the outline. Is that the idea?
Exactly. They call it RLTR, reinforcement learning with tool use rewards. Instead of asking, did you reach the right answer? They ask, did your sequence of tool calls include the necessary steps? A separate language model acts like a completeness checker. It looks at the plan and says, yes, you queried search. Then you called code to calculate, so that plan is complete, or no, you skipped a step.
Give me a concrete example. What would a complete plan look like?
Think of a question like how many days until the next Summer Olympics? A complete plan searches for the exact dates first, then calls a code tool to compute the day difference. If you only search and then guess the days by reading the calendar in your head, the checker says incomplete. The agent learns to always fetch the dates and then compute.
And they only train the planner, not the final answer writer.
Right. The summarizer can be any model. It just reads the observations that the planner collected and writes the answer. Because the planner gathers better evidence, the final answer usually improves, even though you never tune the writer.
How do they keep the planner from gaming the system? I can imagine a plan that calls the same tool 5 times to look busy.
They add small rule-based penalties. Repeated or useless calls get dinged. If the plan is malformed, the reward is a hard negative. The main score still comes from that completeness checker, but those stabilizers keep things honest.
What did they run this on? Any sense of the environment and data?
The setup is very practical. 2 tools only. A Chinese language search tool based on Sogo for retrieval, and a code tool that executes short Python snippets safely. Training uses an in-house Chinese dataset, and they also test on a filtered Chinese simple QA split that really requires tool use. So this is grounded in Chinese production scenarios.
And for baselines, they compare to the usual suspects.
Yes, they include strong off-the-shelf systems like DeepSeek R1 and a large Quen model with no fine-tuning. Then they compare end-to-end supervised fine-tuning, end-to-end reinforcement learning that rewards final answers, planner-only supervised fine-tuning, and the new planner-only RLTR. They try standard RL algorithms too. Think PPO and a couple of close cousins, and the trend holds.
You mentioned numbers up front. Walk me through them without drowning me in decimals.
Sure. On planning quality, which they measure as tool use completeness, RLTR consistently beats end-to-end training by about the size of a solid letter grade shift. That is the 8 to 12% lift. And when you plug that better planner into a normal summarizer, final answers judge for helpfulness or exact match rise by roughly 5 to 6%. The gains are bigger on hard questions, which is what you'd hope if planning is the bottleneck.
Got it. How do they judge all this? Humans or models?
Mostly models. A large Quen model family member acts as both reward source and evaluator. For planning, it judges completeness with a special prompt. For final answers, it judges helpfulness and relevance on the industry set, an exact match on the open set.
That makes me raise an eyebrow. If the same family is judge and sometimes teacher, the scores might be biased.
Totally fair. The authors acknowledge that using a model judge is a practical choice, but not perfect. Cross-family evaluators or human ratings would make the case stronger.
Any other limitations we should keep in mind?
A few. First, the work is centered on Chinese, so we still need evidence that the approach transfers to English or multilingual settings. Second, they deliberately left the summarizer untouched. That proves the planning point, but it also means we do not know how much more we could gain by training both components with carefully separated signals. Third, the tool world here is simple. Just search and code. In enterprise settings, you might have calendars, databases, internal APIs, and the notion of completeness could get more nuanced. Finally, much of the data is in-house, and I did not see a public release, so reproducing the exact numbers may be hard.
On the flip side, it sounds refreshingly simple. Train the dispatcher, not the chef, and use a checklist rather than a taste test.
That's a great analogy. Imagine a restaurant. The planner is the expediter who decides what prep stations to ping and in what order. RLTR grades the expediter on whether they hit every station needed for a dish. You do not need a food critic for every plate during training. You just need to know whether the flow through the kitchen was complete.
Where does the method shine the most based on their analysis?
Two places. First, difficult queries that require multiple hops. The completeness reward forces the planner to change steps rather than stopping early. Second, stability during training. Because the reward focuses on the action sequence, the gradients point more directly at the planner. That shows up as cleaner learning curves and more reasonable numbers of tool calls over time.
Did they test whether their completeness reward is actually more reliable than answer-based reward models?
They did a small manual study. They labeled several hundred cases and compared two automatic judges. The completeness judge aligned better with the human labels than the final answer judge. That supports the idea that process checks are less gameable than grading the end result.
If I want to try this at work, what would the minimum viable version look like?
Start with whatever tools your agent already uses. Write a short prompt that tells a verifier model how to score a plan as complete or incomplete. Add two simple penalties, one for repeating the same call without changing parameters, and one for calling the wrong tool. Freeze your answer generator. Then run a standard RL loop like PPO on the planner only, using that completeness score. You can keep your existing evaluation and just check if planning completeness and answer quality rise together.
And future directions the authors point to?
A few clear ones. Broaden languages beyond Chinese. Mix in human and cross-model judges to curb bias. Scale to richer tool ecosystems. And eventually couple the planner with a summarizer in a way that still keeps the objectives cleanly separated.
Before we wrap, say the takeaway one more time for listeners who might be jogging and only half listening.
Here it is. If your agent struggles on multi-step tasks, stop trying to reward perfect answers. Reward complete plans. Train the planner by checking whether it followed the right steps with the right tools. Do that well, and the final answers get better almost for free.
That is clear and honestly encouraging. Focus the reward where the work happens. Thanks, Noah.
Thank you, Lena. That's today's AI podcast. If you try completeness rewards in your own agent stack, let us know how it goes.